Hello, and welcome to our next lesson, which is sample space. So, the sample space describes all of the possible outcomes of an event. So, let's write that. Sample space can be displayed with lists, tables, or tree diagrams to determine the probability of simple or compound events, and we'll explain that more in a minute. So our first two examples are what are referred to as simple events. So it says the New England Patriots and the Dallas Cowboys are playing. What are the possible outcomes of the game? Well, there's one event going on, and it's a one game. And even though there's two outcomes, we still call this a simple event because there's only one event going on. So the two outcomes are that the Patriots win or the Cowboys win. Our next example is a number cube is rolled. What are the possible outcomes? Well, we're doing one thing. We're rolling a number cube, and we might be looking for different things on the number cube, but we're not rolling a number cube and picking a card or tossing a coin and rolling a number cube. So this is considered a simple event, and the possible outcomes on a number cube would be 1, 2, 3, 4, 5, and 6. So the next series are actually called compound events because two different things are going to go on. So they were going to ask us to make a list or a table. I'm going to choose to list it. So for breakfast, Jamie can choose from cereal, eggs, or muffin. She can also drink coffee, orange juice, or milk. What are all of the possible outcomes? How many total outcomes are possible? So we're going to list the outcomes. So let's start with the first series, and that's basically what we want to eat or what Jamie chose to eat. So we had cereal, eggs, and a muffin. Then it's what she chose to drink, and we have coffee, orange juice, or milk. So with each one of their breakfast items, she could pair it with a different drink. So she could have cereal, and she could pair that with coffee. She could have cereal, and she could pair that with orange juice. So I'm just going to put OJ. And then once again, she could have cereal, but this time she could pair that with milk. So one breakfast item, but three different choices for her beverage. So we're going to start that again because we've taken care of cereal. Now we're going to go back and look at the next choice for breakfast. We have eggs, which we could once again pair with coffee. Then we're going to go back to eggs, and we can pair that with orange juice. And the last is eggs again, but this time it's with milk. So pause the video and see if you can complete what's going to happen if we use muffins. Replay when you're done. So muffins would have three different choices of beverage. So even though there's just going to eat muffin, we're not going to have three muffins. We have a choice of pairing it with a muffin with coffee, a muffin with orange juice, or a muffin with milk. So we've now made our list. We've completed everything. The choice of breakfast, the choice of beverage, and it asks us how many total outcomes are possible. So you may have noticed that there's 3 choices for breakfast and there's 3 choices for a beverage, and if I multiply that, there are 9 choices. And if we count them, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. And what we use here is sometimes called the fundamental counting principle. And I believe I posted a video on that. If not, we'll do that in the future. So now let's look at number 4. At registration, a student can select from Spanish or German class, as well as art, music, and theater. What are all of the possible outcomes? It wants us to list them, and how many total outcomes are possible. So we'll start this again. We're going to start with either Spanish or German, and then our next choice is art, music, or theater. So let's go back and start with Spanish. If she took Spanish classes, she could also pair that with art, she could pair it with music, she could pair it with theater. So we're going to write Spanish 3 times and pair them each with a different art. And by art, I mean the arts. So we have art here, which probably means drawing or working with mediums. We have music, and we have theater, drama. So we've taken care of all the choices if she chooses Spanish first. Now we're going to go on to German. Okay, she could learn German, but German can also be paired with all 3 of those different arts. They sometimes call them fine arts. So we would put art with German, German then and music, and German and theater. So if I look at this, I have 1, 2, 3 choices here, and then 4, 5, 6. So 6 choices altogether. Now, if we look and see, we had 2 choices of language. So we had German or Spanish, and then we had 3 choices of the fine arts, and if we multiply them, sure enough, we get 6. So this lets us know that there's 6 outcomes. So using this tells us how many there are, but using this listing method tells us exactly what the combinations are. So moving on, this time it asks us to draw a tree diagram. A fair coin is tossed 3 times. What are all of the possible outcomes? How many total outcomes are possible? So let's really circle, this is important. We're going to toss the coin 3 times. And each time we toss it, it could be head or tails, heads or tails, heads or tails. So we're going to start this by drawing a tree diagram. And there's 2 ways we can draw the tree diagram. I'm going to start it moving to the right. So I'm going to put heads, and I'm going to put tails. That's after the first coin toss. Whoops, first coin toss. But then when I go to toss it again, I can get heads again, I could get tails again, and this is the second coin toss. But on the first toss, if I got tails, I could also get heads again, the second toss, or tails for the second toss. So if we stopped after our second toss, we would have this. We'd have heads, 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 tails. So that's 2 choices. Tails, heads, tails, tails. So that would be 4 choices. But they asked us at the beginning, it said, we're going to toss the coin 3 times. So now from each branch of the second, I could get, if I toss the coin, I could get heads, or I could get tails. If I toss this other, and I got tails, I could get heads or tails. And now if I go over to the next tree diagram, or down to the next, again, I could get heads or tails. And the last one, heads or tails. So we stop from where, or we start from where we stopped. And this was the third coin toss. So there's different ways to read this, and one of the ways is to look at the very end and look at how many choices. We have 1, 2, 3, 4, 5, 6, 7, 8. And if we wanted to write these combinations out, I would start with the very top. If I tossed a head the first time, a head the second time, and a head the third time, that would be this list. So I'm going to start and work backwards from this one. That would be heads, and then heads again, and then tails. So that would be the second one. And then we go back to this one right here. I'm looking at this one, and that would start with heads, tails, heads. And this one would be heads, tails, tails. And we could keep on going. So if we choose not to do this or make a list, because we're only halfway done, one of the ways we can figure out how many there are is to use that fundamental counting principle. There were 2 choices in the first row, first time we tossed it, 2 times the second time it was tossed, and the third time still 2 choices. So 2 times 2 is 4, 4 times 2 is 8, and if we count, we do have 1, 2, 3, 4, 5, 6, 7, 8. Now I mentioned there's another way to build a tree diagram. So I started mine on the left and moved the branches to the right. But we can start at top and let the branches fall down beneath. So this tree diagram would look like this. Once again, if I tossed a coin, my choices would be heads and tails. That's the first. And then if I toss a coin again, I'd be back to heads and tails. And if the first time I had tails, I would, again, the second toss, my choices would be heads and tails. So this is the second way. And this is preferably my way. I like going from top to bottom, but it's how you like to do it. And then on this third toss, I'm going to start where I stopped. I stopped heads and tails. And if I had tails in the second row, I would have, again, heads as one of the choices, and tails. And now we're going to do the same thing from the branch that comes off of the tails. So we're going to go to the heads, and we're going to say, okay, well, if I toss the coin the third time, I could get heads or tails. And if I would have gotten tails originally in the second toss, I could still get heads or tails for my third toss. So this is my preferred way, but it really doesn't matter which direction you go in. We're going to get the same result. If you look, we have 1, 2, 3, 4, 5, 6, 7, 8. We can count them, or we can start with the first toss. There's 2 choices. Second toss, there's 2 choices. And third toss, there's 2 choices. And altogether, that would be 8. And both ways, we have 8. So now I'd like you to try the problems on the back on your own.